Okay, welcome back everybody. Our last talk for today will be presented by Josef Weingand.
Yep.
And he's talking about contemporary and cost-efficient backups to tape. And after that talk, we will have outside some lunch packages for you. You can pick someone for your travel home. Yes.
Okay. Hello. My name is Josef Weingand. The short name is Sepp Weingand. Now you know that I'm coming from Bavaria, which is a small country in Germany. I work for IBM since about 20 years. Currently, I'm doing the business development for tape products in the region DACH. DACH means Germany, Austria, and Switzerland. I started in IBM as a customer engineer, which means hardware engineer, and I supported customer or repaired products, mainframe, but also storage, which means I work with storage since more than about 20 years. After the customer engineer work, which I have done in Munich, I went to Mainz, which is the support center, the European support center for storage. I worked there for 3 years about and did the support for tape storage products and virtual tape libraries for about 3 years. And since 2001, I worked as a technical sales or sales consulting in the storage area and backup area. Since about 3 years, I'm now responsible for all of the tape products in the region DACH. This is about my history. Today, we heard a lot of backups, but we do not get the real question. Why we are doing backup? We are doing backup because of protecting data. But data are currently the most important value of your company, of your enterprise. So this means we are not only protecting data, we are also protecting your company, your enterprise. And therefore, if you're doing a backup, it must be secure, it must be stable. Because it's not only data, it is about your company. And we are talking about tape. So a real old technology, which is more than 60 years old, but it's still alive. And I will show you that we have still a future for tape. Just a question, who is using tape in the backup environment? Okay, half of them. So the rest are not using tape, is this correct, in the backup? May I get the names of the people who are not using tape currently? I will go to them and talk to them after that. Or maybe you will see that in the future you will need tape. I will talk a little bit about storage technology, what will be the future about storage technology, but also about the tape storage technology. We have done a lot of research in Rüschlikern, and I will show you this. Then I will talk about the advantages of tape, why you're still using tape or why you should use tape in the future in your storage environment. And also I will show you some different solution architectures, how you can combine different storage technologies in your backup environment. Of course, most of the times, or most of my customers, because I work for IBM, are TSM customers. But I also work with customers who have different backup applications like Legato Network, Semantic Net Backup, but also some others like Barreros or some others tools, also which using IBM tape libraries, of course. Have a look to the bits which are stored on our storage. If we look on the different sizes of a bit on our storage, on the bottom we see a bit on the tape storage, which is huge compared to a HDD. On a HDD, it's just this size. On a flash storage, it's this size, and we have an areal density on the flash storage currently of about 1,500 gigabit per square inch. On the current tape technology, LQ6, we have an areal density of about 7 gigabit per square inch, and it's this size. If we look in the future, how we can store more data on the same size of a storage, we have to shrink the bit, of course. And it's not easy to shrink the bit on a flash. It might be easier on flash than on the HDD. We will see this later on. But compared to tape, we have a huge room to improve the size of a bit. And we have done this. Currently, we have 7 gigabit per square inch. And we have already proven in Rüschlikon, close to Zurich, that we have areal density with a current technology. We can write an areal density of 123 gigabit per square inch, which means on a current tape cartridge, the size of a LTO6 tape cartridge, we can store 220 terabytes capacity, uncompressed capacity, on one size of a tape cartridge. Can you imagine this? How much capacity do you have? And how many cartridges do you would need with the 220 terabyte cartridge? Just a few, maybe. Yeah. You can even store with 220 terabytes about 1 year full HDD movies. It's the size of about one tape cartridge in the future. So we have proven this in Rüschlikon with the current technology. This looks like a tape drive, and also the media here. It's a barium ferrite media, which we use on LTO6 since about 3 years. And this is the media which we will use for the next 10 or 15 years. Yeah? So the demonstration of the 220 terabytes is a demonstration of a current technology, which we already use in our products. Yeah? And we can use this demonstration to show the market that we have a stable roadmap for the next 10 to 15 years to increase the capacity on a tape drive. If you look in the history and the areal densities, the blue dots here are the demonstration which we have done in Rüschlikon. The last one is this one. And the green dots are the products which went out from the development. Over the last 20 years, we increased the capacity on a tape cartridge per year about 30 to 40% per year, which means from technology or from generation to generation, we doubled the capacity every 2 to 3 years. We have done this, for example, with LTO 1, 2, 3, 4, 5, 6. Every 2 to 3 years, we went out with a new generation, and the new generation has a doubled of the capacity. And we have done this over the last 20 years. If you look in the future with the demonstration, what we have done recently in Rüschlikon, we get to a point of 2025, which means for the next 10 years, we have a stable roadmap, which means we can go out with a new generation of a tape product and double the capacity every 2 to 3 years. Yeah? And in about 10 to 15 years, we have a tape cartridge out with about 220 terabytes capacity, the size of a cartridge. Compared to some other technology, like the HDD's technology, the last lab demonstration for hard disk drives was in 2012. And since then, we do not have any new technology, even not in the lab, to demonstrate that we can write higher capacity on a HDD. Yeah? And the last few years, all HDDs which we get from the market have no higher areal density. The last HDD with higher areal density was the 4 terabyte disk drive. Of course, we get the 6 and 8 terabyte disk drives, but those disk drives does not have any higher density. Those disk drives are helium-filled disk drives, which means we get other packages in the size of a 3.5 inch HDDs. Formerly, we had about 5 patterns in one disk drive. With the helium-filled disk drives, we have 7 or 8 patterns in the disk drives. And therefore, the disk manufacturer were able to increase the capacity per hard disk from 4 terabyte to 6 and 8 terabyte. Yeah? But after the 8 terabyte disk drives, there is no information how to increase the capacity further on. Of course, we are talking about the 10 terabyte disk drives, but those disk drives are shingling technology. Shingling means overlapping writing. which we have done on the tape technology since more than 15 years, which means we are writing one track and then overlapping the last track to get a smaller density or to a smaller track density. Yeah? But those disk drives are not random access disk drives, of course for reading, but not for writing. So this means on a shingling disk drive, you can just write it once, or you need to write a huge capacity to write it once, but you cannot overwrite it, like we have done as currently on our disk drives. Yeah? The next big technology step in the HDDs are the heat magnetic recording assistance, which means with a laser we get some heat on the magnetic structure to change the bit. And with the heat magnetic recording assistance, we are able to write higher areal densities. But this means we need not only the magnetic heads in our disk drives, we need also laser heads in our disk drives. And you remember we had 5 patterns, 6 or 8 patterns in our disk drives, which means we need 8 laser heads in our disk drives to get higher capacity. So this might be the next big step in the future, but this is not coming out in the next 2, 3, 4 years. So the future means for HDDs, the increase in capacity is slowing down currently. And there will be a new technology, the heat magnetic recording assistance here, which get higher capacity. But there's no roadmap or plan when we get such a production. On the flash technology, it is easily to increase the capacity with different function and technology. The expectation is to increase the capacity compared to today in the factor of 6. And the tape areal tape capacity, we have proven this, that we can easily increase the capacity for at least the next 10 to 15 years with a yearly increase in capacity of about 30 to 40%. On the flash technology, we can either shrink the bit or the technology, the manufacturing technology to get higher areal density. But currently, the biggest advantage is to doing a 3-bit stacking to get higher areal densities, which means not one layer on the cells, but get more layers on a cell to get a higher capacity. This will be the next big step in the flash technology. And with this technology, we can easily overtake the hard disk drives on capacity-wise. On the areal density discussion, this is a slide from Hitachi, which tells the market that the data growth is much higher than the increasing capacity on the technology. Even Hitachi tells us that we get an increase in the capacity of about 15 to 20% per year. What is the problem? Up to now, or the last 10, 20 years, the increase in capacity on the HDDs was about, we see this on this slide, in about 2 years, in 2000, we get an increase in capacity on the HDDs about 100%, which means each year we get a new HDDs with a doubled capacity. Yeah? But this is now slowing down the increase. But in the last few years, we had always at least a 40 to 50% increase in capacity. And we do not thought about the data growth in our data centers compared to the increase in capacity per HDDs. So in the last 10 to 15 years, there was no problem, which means the HDDs capacity was much higher than the data growth. But in future, there will be a change because the data growth is 35% in average, and I think also in your company will be between 30 to 40% data growth. But the HDD technology will get only an increase in capacity of about 15, maybe 20% per year. And in 8 years or 10 years, we get a gap, which is a factor of 3. which means in 8 to 10 years we need to install 3 times more HDDs as we have currently installed. Yeah? And this was not in the past. In the past, if we replace storage systems, we get a new technology, new HDDs, and normally we install the same number of HDDs compared to 3 years ago, because of the increase in the capacity per HDDs. But this will be not true in the future. And here are some example. If we have a disk-only backup with 600 terabytes, we need today about 300 HDDs, and there's a power consumption of 7 kilowatts. 7 kilowatts. If we replace this storage system in 3 years, and due to the data growth, we need a capacity of 1.8 petabytes. And in the past, we would install the same number of HDDs. But in future, we need to increase the number of HDDs. So in 3 years, we need to install 750 HDDs, which leads us to a power consumption of 18 kilowatts. This is just one example, but this gives us the hint that we need to rethink in our storage technology. Yeah? And therefore, the rethinking leads also that the tape backup is not dead. Yeah? We still need tape to store our data. And in addition, we need also to think about to store some data not only on disk, but also on some other technology. If we look on our NAS systems, NAS means for most people's network-attached storage, but normally a NAS system is also a never-access storage. 80% of your data on a NAS systems will be never written or read from the user after 4 weeks or 6 weeks. 80% of the data on a NAS systems, therefore never access storage. And therefore we have to think about those data and put it in the future on a lower cost storage tier. And therefore we have developed linear tape file systems to easily manage data between disk and tape. And the linear tape file system makes for tape file systems, which means you can use your tape drive on your server. Here's an example with Windows, but of course it works also for Linux. You can easily put it on your file systems, and you can easily move data between HDD file systems and a tape file system. Here in this example, this could be HDD, but it could be also tape. And you can easily put, read or write data directly to tape from your file system. Yeah? And this is the linear tape file system. And with this, we will put in the future more data transparent to the user, moving data out from the disk system to tape system because of cost and because of the capacity. And this is also the reason why nowadays, or starting last years, more and more of the press on the internet, on storage consortium and so on, you can read more and more articles about tape. The tape is not dead. And you get a lot of information why tape is not dead. You get this also today in this presentation, but you can use this articles also to give it to your colleagues. Some points here is combination of flash and tape. And here you see also that maybe the HDDs will die before the tape dies. Yeah? In 5 years, we will not using any more HDDs. We will using only flash and tape. Yeah? And therefore, there's a new combination or new word. It's called FLAP, the combination of flash and tape. And there's no room left for the disk technology. Yeah? Because on the flash technology, you get higher performance, you get higher capacity, and on the tape technology, you get highest capacity for the lowest price. And the combination, the best combination, will be in the future combination of flash and tape, which is called FLAP. But also, some others recognize that tape is a really reliable storage technology, and I will show this you also. If you have data on tape, it is really secure on tape compared to disk drives. Yeah? And also, the disk costs will not go down as we have seen this the last few years because of the helium-filled disk drives, but also in the future with the heat magnetic recording assistance. The manufacturing costs for disk drives are not shrinking anymore, and therefore the price per gigabyte is not falling down, as we have seen this in the last 10 years. Now coming about data security, the protection of data. One point I say bit error rates. Nowadays, the bit error rates on a tape drive is much higher than on a disk drive. For example, you can write more data on tape. It's about 1 exabyte more data on tape before you get 1 bit failure compared to the disk drives. Here are some examples. A nearline SAS has 10 to 15 bit error rates, which means you can write on a nearline SAS drive. A nearline SAS is here. You can write about 110, write or read, 110 terabyte, and then you get the first bit failure. Yeah, which means it might be a data loss after 110 terabytes. Yeah. And if I compare this in an example, or if I do some calculation with this, in a backup environment, if you backup daily 50 terabytes per day, and you have a capacity of 2.5 petabytes in your disk backup area, you will get 1 data loss after 2.5 years. Yeah? And if I talk to a huge cloud provider and so on, they have petabytes of data, and they replies to me that they get at least half a year 2 RAID failures where they have data losses. Yeah? Compared to tape, you get a data loss after 62 years. Yeah? 10 years ago, everyone replied to me that tape is not reliable, you get broken tapes and so on. But nowadays, we even give you on IBM tape cartridges a lifetime warranty. Yeah? If you buy 1 tape cartridge from IBM, you get a lifetime warranty for this cartridge. And we can do this because from 10,000 cartridges out, we get just 2 broken tape cartridges back. Yeah? From 10,000 cartridges, 2 are broken. In addition, we have a huge error correction on our tape drives. We are doing a kind of RAID 6 in our tape drives. And with this kind of RAID 6 error correction, we can recover media failures of about 11 millimeters. This means if you have a tape, and on this tape you can have 1 failure which is about 11 millimeters big, and we can even recover this data. The most important point about tape is an offline media. You cannot delete it, you cannot change it, you need to override it. Yeah? Compared to a disk drive, just 1 command and all your data are lost. Yeah? If you do a configuration change on your RAID systems, if you do a format, you lost all your data, which in a few seconds on your disk drives. Yeah? Or also some software failures. If your RAID systems protected with software, and if you do a software update, it is easily that the software is broken and all your data get corrupted. Yeah? It happens several times that you lost data on the disk systems because of different failures. Also, what we have discussed yesterday evening on a beer, if you sing on a data center and you are not able to sing in the way like I do, you can go to your data center, sing, and then you might lose some data. Maybe not with sing, but with the fire protection systems in your data center, it gets a lot of noise if this gas comes out. And we have several incidents in Germany, but also worldwide. If you use this fire protection systems, then some of your data are overwritten, or even your HDDs are broken because of the noise. Yeah? Here are some hints where you can read it. About the error correction code, I told you on tape we are using a kind of RAID 6, and the parity bits we are stored, one parity bits stored in this way, and the other parity bits stored on the whole tape cartridge. Yeah? Therefore, we have a kind of RAID 6. And with this kind of RAID 6, we can recover tape errors or media errors of about 11 millimeters, and we can still read the data. Many customers are using tape, and one of the biggest customers in the world which using tape is Google. We do not exactly know what Google is doing. Maybe they are backing up the whole internet each day on tape. So, which means if we get a blackout on the internet, Google is able to restore the whole data. On the Google blog, you can read it. They had 2 years ago or 3 years ago software, a broken software, and this broken software corrupted the Gmail's users. About 140,000 Gmail's users or data were deleted by this corrupted software. And Google is storing the data on 3 different places, but this software was also responsible for the replication, which means they have destroyed on one side the data, but because of the replication, they have destroyed it 3 times. Yeah. But Google was able to restore the data because they are doing some backup to tape. And Google is also telling the audience that tapes are offline and they are protected from such software bugs. Yeah. Of course, Google is doing a kind of disk backup, but for the last line of defense, they are doing a tape backup. Yeah. And you should keep this in mind. If you're doing disk backup, you need also the last line of defense, and this is a tape or offline backup. And one big customer, Google, is doing this. So I showed you some facts why tape is not dead. Because of the capacity in the future, reliability is much higher, costs is cheaper. We will see this later on, that tape is even cheaper than any other disk technology. This was technology. Now come back to the products. And here's the roadmap of the tape products which IBM is producing. We have, of course, the LTO product, but we have also the enterprise product. Let's first have a view to the LTO roadmap. Every 2 to 3 years, we get a new generation out, which means the last LTO 6 was out in November 2012. So now you can add 3 years, and you know when LTO 7 comes out. October 2012 will be now. Not now, but next week. I have not told it because it's confidential, but you can calculate it. LTO 7 will come out soon with a capacity of 6 terabytes. And we increase the performance from 160 to 300 megabytes per second. This is uncompressed capacity, uncompressed performance. With compression, we can store up to 15 terabytes on a cartridge, and we have a performance of about 700 megabytes per second with compression on one tape drive. We have also an enterprise technology. The generation 5 on the enterprise technology comes out last year and had already a capacity of 10 terabytes. Which means if you have a huge capacity, you should look for the enterprise technology because we get here higher capacity on one cartridge. By the way, the human brain can store up to 10 terabytes capacity, between 7 and 14 terabytes. Which means you can easily dump your brain on a tape cartridge. I have done this several times. I want also do some restores. But the restores were always failing because I got a failure message which told me no brain detected. I do not know why. So here you get some information about the LTO 7 technology. This will be not in the handout. If you need some information, call me or write me a mail next week. Then you get all this information about LTO 7. I told you already 6 terabyte capacity and a performance of 300 megabytes per second. This means it's nearly a double of the performance. This is not easy to make, to double the performance, but if you look at the tape drive, up to LTO6 use on head, tape head with 16 tracks, which means we are writing 16 tracks in parallel with LTO6. If we now double the performance, it is easy if we increase the number of tracks from 16 tracks to 32 tracks in parallel, which means the LTO7 tape head has now 32 tracks, which means we are writing 32 tracks in parallel. And therefore, we were able to increase the capacity from 160 to 300 megabytes per second. But we have also speed matching, which means not only the 300 megabytes is the performance, we can easily switch down the speed of the tape drive to match the speed of your server or your client. This is needed to avoid the start-stop problems on a tape drive. Start-stop problems or shoe shining effects are done, or this was an effect 10 years ago. Since more than 10 years, we are doing a kind of speed matching, which we match the speed of your server, and this avoids any start-stop problematic. Okay, now we are doing with 14 speeds. Okay, this was LTO7, just an overview of all tape products what we have. The LTO technology, the enterprise technology, and normally the tape drives are installed in tape libraries. We have different sizes of tape libraries. Smaller one libraries starting with 9 slots, going to 22 and 44 slots, and then a scalable library. The large library is scaling. Scales very well, starting from 58 slots and goes to up to 20,000 slots. And you can even combine some libraries and then you get 300,000 slots. Then you might store up to 1 exabyte on one tape library string. Of course, we have also disk products for the disk backup environments. So it means we have a whole set of storage products to store your backup data. This is the enterprise product. I will skip this one. I will go to the tape libraries. A short view here. This is a small one library, 1 tape drive with 9 slots. It is 1 U high. And then the next one is a 3100 tape library with 2 U highs, and the 3200 libraries with its 4 U's high. Here you can have up to 2 tape drives, and here you can have up to 4 tape drives and up to 48 slots. With LTO7, you can store on this library 280 terabytes uncompressed, or with compression you can store on 1 tape library 720 terabyte on this smaller 1 tape libraries. Okay, we have also some scalable libraries going from 35 slots to 400 slots. And this is our biggest one, enterprise library, where we can connect up to 15 libraries together to get 300 slots, and you can store 5.7 exabyte on 1 string. If you have one of this capacity, some exabytes, please give me your business card. I will go to you and look what happens if you have some exabytes on data. So, of course, we do not have many customers worldwide who need some exabyte on 1 tape library. Okay, now we have seen the tape products. Now let's have a look how we can combine the disk backup and the tape backup together. First of all, keep in mind that 42% of small companies have experienced data loss, and 32% of those have lost the files forever. Therefore, backup is important. And it must be secure, your backup. And if you look about why we lost some data, of course we have some hardware errors. And in my experience, the number of hardware errors are increasing because of the huge HDDs. With 6 terabytes or 8 terabyte disk, it takes 2 to 3 days to get an array rebuild done. And during these 2 to 3 days, you might even get a double bit failure, and which means your whole RAID array is broken. Yeah. But you get also some sabotage. And the storage administrator has the highest risk in your company, because the storage administrator can easily delete or change the configuration on your storage subsystem, and therefore you can easily delete all your data in your company within some seconds. Yeah? And this is the reason why the storage administrator should get the highest salary in your company. If not, then you need at least to install some tape backup, because tape backups are offline. The highest reason why you get data loss is because the failure is sitting 20 centimeters in front of the keyboard, which means it's the human errors. In my small company at home, I have 3 ladies, and I get about 39% human errors if someone lost some data. But this is because I am not able to educate my wife, but this is a different problem. So the data protection trend, or what we still have problems, is the data growth, of course. We are talking more and more about cloud backup. Most data are backups with snapshots currently nowadays, and we are still talking about media matters, like disk backup or tape backup is still needed in our environment. If we make an overview about backup, then we have, first of all, we have our data, production data, which are normally mirrored on the disk subsystem. And the first step of data protection or backup is to doing some snapshots of those data. Some customers call it data protection. But this is not enough, because if you lose some subsystems, you lose also your backup, but also it's all online data, and it's managed with the same software. For instance, the Amazon Cloud is doing one of these backups, and just doing this kind of backup, and they have several times lost data. Because with snaps, you can just restore once the data. If you choose the wrong snap, then all your data are lost. And if you have some software failures or data corruption failures, even your snaps will have some failures. Yeah? And therefore, you are not able to restore all the time the data from snaps. And this is the reason why the data on the Amazon Cloud are not secure enough. If you read some blogs, you will find every time or several times some data losses on the Amazon Cloud. Therefore, you need backup. Backup, the classic backup restore with some backup server. Of course, today the backup server is Barreros. You can have, of course, some others backup, but I changed this today. And behind the Barreros or backup server, you get a disk tape, and maybe you get also some virtual tape libraries backups. And then you need the disaster recovery, which means you need a different location to put your data. Either you do it electronically, move data or copy data to a third site, or you can even move some data to the cloud. Yeah. This is the whole picture. And we will now discuss some different solutions behind your Barrero servers, a combination of disk and tape. One point is you can, of course, store everything on disk. But with tape, you get an offline medium, as we have discussed, but also you can shrink your costs. There are different white papers out which shows you if you do a combination of disk and tape, it's a cheaper than doing disk only. Yeah? And this is the reason why I want to show you some combination of disk and tape. We will skip this one and go to the different solutions. We can combine a disk to tape backup. Maybe in the future we will replace the disk with flash technology if you need high performance in your backup environment. We can do a tape-only backup and disk-only backup with a copy to tape and the combination of it. About tape-only backup. The problem or the disadvantage of tape-only backup is the restore time or the access time. Yeah? Because you need spool your tape drive to get your data. Nowadays, tape cartridge is about 800 meters long, and you need to spool it to get your data. However, we spool on a tape drive with about 14 meters per second, which is about 15 kilometers per hour on one tape drive. Yeah? 15 kilometers per hour, you can try it with your bicycle, and then you figure out how fast is a tape drive, 50 kilometers per hour. However, the access time to data on a tape is below 40 seconds, but you need to mount it from the tape library to the tape drive and so on, which means you have access time of about 60 seconds on a tape drive. Which means if you have a small file sizes on a tape, you need to wait at least 60 seconds to get your data. Compared to a disk systems, you get it in just a few seconds. Yeah? However, the tape is very fast. We can read the data with up to 700 megabytes per second. And if you can read the data in this performance, tape might be faster than disk compared with disk technology you're using. And in this example, what I calculated for a customer is if you have file sizes larger than 10 gig, tape might be at the same speed or even faster than a disk technology for restoring the data. And this is also the reason or the point, if you backup data and if you, the reason why you choose a tape direct backup is for big data. Yeah? Databases larger than few hundred gigs, you are backing up directly to tape. It is cheaper and faster and even for the restore. Yeah? And some calculation. Here is for enterprise technology. I have compared a database which is 2.5 terabyte big or large, and we need to backup it in 1 hour. I need 2 tape drives to backup it in 1 hour, compared to disk systems where I need 70 terabytes capacity to get the performance. Performance is 720 megabytes. And if I compare the costs on a street level price, I calculated on the price of a tape drive, which means on the disk systems, it's 3 times more expensive than a tape-only backup. Yeah? If you're doing in this area disk backup. I have done this also for smaller sizes. This is a small tape library with 2 LTO6 tape drives. I get a capacity of 60 terabyte native or 150 terabyte compressed. And if I compare it with entry disk systems, where I get in one shelf 72 terabytes capacity, this is about 2 times more expensive than the tape, or 1.6 more expensive than one tape library. Yeah? I compare the 72 terabytes to this 60 or 150 terabytes. Yeah? So this means even on a lower capacity, the tape is cheaper than the disk systems. Of course, if you compare just a few terabytes compared to our tape systems, the few terabytes will be cheaper on disk because you do not need the tape drive compared to the tape drive. On a tape drive, you need the tape drive, the cartridge, and maybe the tape library. Therefore, it makes sense to use tape if you get more capacity. Here in this example, if you have more than 60 terabytes, tape is in the same range or even cheaper than disk system. But normally we do a combination of disk and tape. and therefore it means from the Barrero server we're doing first a disk backup, and then later on we're doing a copy or a migration to tape. Some examples how we can do this. This is a two-site location where we have two sites, a backup server. We're doing first the backup to disk and then migrating it to tape and doing a copy to the second site. In the future, maybe we will discuss more about flash backup, which means a disk pool, or not a disk pool, a flash pool. And I have done some calculation also here. Currently, flash or SSDs make sense and might be even cheaper than disk if you need a high performance. In this examples, if you need a performance more than 10,000 megabytes per second for backing up, then the flash systems is cheaper than the storage systems. And nowadays, even the customer are starting, and we have 1 year ago already one customer who are using flash in the backup environment. Yeah? And this customer is doing backup to flash on the first stage and then migrating it to tape. Yeah? Of course, it's a huge customer who is doing backup of more than 350 terabytes per day. The most environments, also in the mid-range environment, would be to have the first copy on disk and do a copy to tape. Yeah? Which means you have the first stage on disk for the backup, but also for the restore and for the protection. On a different site, different location, you have your tape system, yeah? On a different location to be secure. And even if we talk about data deduplication, some years ago data deduplication was a hype. Nowadays, most of the customers recognized that the dedupe rate ratios, which was maybe 5 years ago 10:1 or 5:1, are shrinking because of encryption. Most of the users are encrypting the data, and the encrypted data cannot be deduplicated. Or if you get in-memory databases, we have already a compression enabled. Also, those data cannot be very well data deduplicated. Therefore, the dedupe ratio goes down, and in average, what we are seeing is a dedupe ratio between 3:1 and 2:1. And with this ratio, if I've compared it to tape, it is even 3 times more expensive than a tape library. Here in this example is about 1 petabyte on a huge disk systems. With data deduplication, we can store 2 petabytes on disk systems, but compared to a tape library, it is 3 times more expensive than a tape library, even with a dedupe ratio of 2:1. Of course, everything depends, and this should give you just a few examples how you calculate some different storage environments or backup environments. And I hope I could show you that tape is not dead and tape has a huge future. Now the question, which questions do you have? Yeah.
You said something before about some linear access to the tapes. So is random access, is that right? Did I understand correctly?
Linear access to tape?
Yeah, random access.
Random access, no. Tape is still a sequential device. Yeah, and we need an access time. It's about in the range of 40 seconds. Yeah. But if you have huge data, in this example was more than 10 gigs, there's no problem with the access time, because if you have located your tape drives and then you're reading the data, then the access time is no problem. You have just once it for 60 seconds with the tape library. Yeah. My discussion was about the shingling disk drives, because on the shingling disk drives you get the same problems with as with tape. Yeah. Yeah.
Is there any physical difference between Is there any physical difference between archiving tapes, read-once tapes, and read-write tapes?
So physical difference, no. Of course, we can have warm tape cartridges, which you have, which you can use it for archive, write it once and read it many, and you cannot change or overwrite the data. But physically, there's no difference on it. Yeah. And you can store the data on a tape cartridges up to 30 years. Yeah. But after 30 years, you do not have any tape drive left to read it. So. Some more questions? Thank you for your attention, and I hope you will use a lot of tape drives in your backup environment.